Hey everybody, this is Larry. This is day 24 of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. I'm not gonna lie, this video is probably gonna be a little bit crappy. A little bit of a disclaimer already and setting low expectations. My marathon is in 3 days or something, 4 days. It's on Sunday. So I am just trying to sleep as much as I can and resting and all these things, but my body is just, in a lot of, it's doing a lot of things. So yeah, we'll make it quick. We'll come back to our regularly scheduled Leetcode videos on next week. But today we'll see how it goes. Today we have 951 flipped equivalent binary trees. For a binary tree T, we can define the flip operation as choose any nodes to swap the left and right. Okay, that seems pretty straightforward. Oh wait, I misread this actually. Maybe, I don't know. I thought that you're supposed. I misread this a little bit, and that I thought they're giving you a tree and you're supposed to flip it. But now let me see what flip equivalent means. I feel like it is as intuitive as I think it is, but I'm struggling to understand the 4-5 part on 2. Some number of flip operate. Oh, so you don't have to flip everything. It's The key thing to note is that each tree has unique node values, actually. The reason why that is important is because there are now no decisions. I think these are things that you have to figure out, and when you're when you're starting out, you might not know these things, and you may and that's okay. But I think the first question that you might ask is that, like let's say you have a tree that is all the same value, right? Well, what's going to happen? Well, what's going to happen is that you can't decide whether you flipped on this current node's children or not, right? So you have to try both ways, and because you try both ways, and there's really no way to escape trying both ways, you can create an exponential test case or exponential input very easily, right? And as a result, then you're like, well, if that's the case, that's going to be not great. So what can we do? Well, the one thing that we can do is check the constraints to make sure that it is unique. Because if it's not unique, as I said, you can make this very expensive. But the thing is that this one is unique, though. And why does that fix things? It's because then now you don't have a decision, right? Meaning that if the left side matches the left side, then that's good. Or if the left side matches the right side, then there's only one choice, really, right? Because everything is forced because there's only one way to match if there's a match. So okay. So let's just write it this way, right? And I guess I don't know. I know that some people don't use the helper and they could kind of just like write it in terms of this one, but I don't know. I prefer, I don't know. My head doesn't think that way, maybe. But yeah. So then here, if node 1, so what are the base cases, right? So if node 1 is none, is equal to node 2 is none. Wait, that's not true. If node 1 is none and okay, we could just do it. If this is true, then well, if node 2 is none, then we return true, else we return false, right? So maybe here you can just return node 2 is none, right? Equivalent. Oops. And then in other cases, if node 2 is none, and we know that node 1 is not none, because, well, that would have been that, right? So then now these are our base cases. It's just to establish the case where one node is none and the other is not none, and that should be good enough for us to kind of go, right? And as I say, then now, yeah, if node 1 dot value is not equal to node 2 dot value, we return false. Otherwise, then now, there are really only 2 ways to match, right? So we either match recursively, node 1 dot left with node 2 dot left, and in this case, then now both of these has to be true. Oops. Or, so you have this thing, or if they flipped, right? So then now in that case, then node 2 dot left, node 2 dot right, node 1 dot right, node 2 dot left, and that should be good. The reason why we don't need additional if statement is because on this we have this thing here, and also we check the case where one of them is none. So yeah. And I was going to test an empty case, and that's good. Or like these empty-ish cases. Because that's one of the constraints that we can think about. I think there may be some other random feeling ones, but I'm a little bit lazy today, as I said, so I'm just going to YOLO submit. Hopefully that's good, and that is good. 1668 day streak. 0 milliseconds into the sketch bit. But I did this last 5 years ago in Java for some reason. Maybe someone requested it in Java. But yeah, it seems like I mostly did the same thing, really. So yeah, so that's good. I wrote this in a funky way. But yeah. So what's the complexity here, right? So we actually look at each node only once, or all of one, sorry. Because we can't look at, we either compare node 1 dot left to node 2 dot left, or we compare this one to the other side's right side. And every node we only make 2 comparison, right? So this should be pretty good. Linear time and linear space due to the size of the stack, and that's pretty much it. That's all I have for this one. I know that maybe I didn't go over it enough, but these are problems that I expect y'all to be able to solve for interviews. So definitely, if you feel like you're a little bit slow on this, definitely practice this up. Yeah. I'm gonna go lie in bed being lazy. I don't even think I'm sleeping, just being lazy for a little bit. Thanks for watching. Stay good, stay healthy to good mental health. 4 more days or 3 more days to marathon. So yeah, stay good, stay healthy to good mental health. I'll see y'all later. Take care. Bye bye.